Hello, my name is Sid Parker, and this is my CHE120 experiment number 6 lab report. So I'm going to start with part E, our iron thiocyanide equilibrium. And so our iron 3 ions could be categorized as sort of a yellow color for this instance alone. I kind of made them an orange color just so you can see it. And our AgSCN ion, negative ions, are a clear color, and our AgSCN 2+ ions are a deep red color. So for this experiment, we started off with FeNO3, which was clear in the test tube. And we had our AgSCN, which was also clear in the test tube. And then when we added these two together, they made that nice dark red color, that FeSCN 3+. So how this sort of relates to equilibrium is when we added more FeNO3+, so we increased our reactants, which caused a right shift and making that nice deep red color. Similarly, when we increased the AgSCN, that was also a right shift, and that's also why we had the similar dark red color that popped up for us. So with the inclusion of heat, actually the opposite happened, and it sort of got lighter. So if you remember our Fe3 ions being sort of yellowish here, when we added the heat, we can sort of assume that that's a reactant. That would have been a left shift. Then we can also go ahead and assume that this is a exothermic reaction. We sort of get this because, again, it's a left shift changing the color, but we are releasing heat. It's one of the products. So the last part that we did for this part E was when we added AgNO3, which caused our test tube to become white. Well, it was more like a sort of clear with precipitate in it to make it look like a cloudy white sort of color. But if you remember our SCN minus was clear, but I do believe this made AgSCN, which was our solid, and the cloudiness was perhaps caused by the solid AgSCN as it was forming. And that about wraps it up for part E. Moving on. We are going to talk about part D. So part D started off as this nice red, sort of pinkish color, which is the COH206 2+ ion is a pinkish color. And then our cobalt chloride 2- is a blue color. So we started off with this red color. And then when we added HCl, we added it, so that's a reactant. This caused a right shift, which is why we had that nice blue color, which was the cobalt. So when we added heat, it stayed that blue color, it didn't change. So our heat didn't end up actually contributing there. But when we took away heat, so I guess when we took away heat, it became sort of a lavender color, or like a, I guess closer to the pinkish. Not really, but you could perhaps consider it more pink than blue, than it was previous. But that would have been a left shift, because we're getting that again. We're getting that lavender color over here. But opposite to the last one, that would make this an endothermic reaction. And so for part F, which is our bicarbonate carbon dioxide equilibrium, it started off with a blue color that sort of turned into a lighter green color and then back into the blue again. So the thing that we added for this was the HCl. And it bubbled and turned greenish. So then when we used aspiration, it went back to the blue. So I'm going to sort of conclude from this that because we started blue, and the HCl is what caused the color change to undergo, which was removed by the aspiration. I'm going to say that it was the HCl that was removed from the aspiration. And if that's the case, I'm going to say that this was because we added the HCl, I'm going to say that's a right shift equation. And then we lost at the end of it, after the aspiration, we lost the HCl, again if I'm correct, which caused it to be a left shift because we lowered one of the reactants. Alrighty, and that about wraps it up for this video. Thanks for your patience, and thank you for watching. I hope you guys have a lovely night. And stay safe out there.